This is part 2 of the sum and difference identities for sine and tangent, and these examples will be really good to watch for your second part of the 5.4 homework. So we're going to start off with finding the cosine of 2 pi over 3 minus theta. And just because we're doing the sum and difference identities for sine and tangent doesn't mean we can't go back and do the difference identity for cosine. So we're going to use that difference identity. Okay, so make sure that you have your identity worksheet available. And for these, we're not allowed to have any additions, subtractions, multiplications inside our parentheses. They need to be single functions of either theta or x. All right, so this is going to be sine of 2 pi over 3 sine of theta. All right, so I know 2 pi over 3 is a Q2 angle. So cosine is going to be negative, and 2 pi over 3 is going to have a reference angle of 60. So the cosine of 60 is 1/2, so that's negative 1/2 cosine of theta, plus sine is going to be positive in Q2, and it's a 60-degree reference angle, so that's going to be radical 3 over 2 sine of theta. And you notice both cosine and sine, they have just a single function of theta, so we're good there. There's no additions, subtractions, or multiplications inside that we're taking the sine or cosine of. All right, so we're going to do the same thing on our next example, but this time we're going to use our tangent, the sum identity for tangent. So if we plug in, this is going to be A, that's going to be B. If we plug A and B into our formula, pi over 4 and x into our formula, we get the tangent of pi over 4 plus the tangent of x over 1 minus the tangent of pi over 4 tangent of x. And I know that pi over 4 is a Q1 angle, and that's a 45-degree angle. So the tangent of any of my 45-degree angles on my unit circle are either 1 or negative 1. So in Q1, it's going to be a positive 1. Tangent of x over 1 minus, when I plug in a 1 for this tangent of pi over 4, I just get the tangent of x. So when I look at my trigonometric functions here, they are only of a single variable, okay? So this is a single function of x. So I'm good here. This is my final answer here. Okay, so now we're going to use our sine identity for this one. We have the sine of 3 pi over 4 cosine of x minus the cosine of 3 pi over 4 sine of x. So 3 pi over 4, this is going to be a Q2 angle. Sine is going to be positive in Q2, and the reference angle is going to be pi over 4 or 45 degrees. So I know the sine of pi over 4 or 45 degrees is radical 2 over 2 cosine of x minus cosine is going to be negative in Q2. So this is going to be a negative radical 2 over 2 sine of x. And when I fix my double negative, I get the radical 2 over 2 cosine of x plus radical 2 over 2 sine of x. And again, this is a single function in terms of x, so I'm good there. Okay, so now we're going to move on to the next type of problem you'll see on your homework. We're going to find the sine of s plus t, tangent of s plus t, and from the sine and the tangent, we should be able to determine what quadrant s plus t is in. All right, so all of the formulas for the sine and tangent of s plus t require the sine of s, cosine of s, sine of t, cosine of t, tangent of s, and tangent of t. So I'm going to start off first by finding those values. And they've already given me some of them. Sine of s is 3/5. Sine of t is negative 12/13. All right, so they didn't give me too many of them. I still have to find 4 of them. Well, let's use the Pythagorean identity of sine squared plus cosine squared equals 1. So we're going to start off with S. So sine squared of S is 3/5 squared plus cosine squared of S equals 1. So that's 9/25 plus cosine squared S equals 1. So cosine squared of S is going to be 16/25. Now I need to make a decision. When I take the square root, do I want the positive or the negative? Well, it tells me that S is in Q1, so I definitely want the positive. So my answer is going to be 4/5 for cosine. Well, let's do the same thing for the sine of, or the cosine of t. So I know the sine squared of t is going to be -12/13 squared plus the cosine of t has to equal 1. So when I square -12/13, I get 144/169 plus the cosine of t, oh, I forgot the squared there, equals 1. And then cosine squared of t is going to be 25/169. So now I need to know, do we want the positive or the negative square root? T is in quadrant 3. So cosine in quadrant 3 is negative, so this one we want negative. So when we take the negative square root, we get -5/13. So to find the tangent and the tangent of S and the tangent of t, that's just a matter of taking ratios of sine and cosine. So the tangent of S is going to be 3/5 over 4/5, which is just going to be 3/4. And then the tangent of t is going to be -12/13 over -5/13. So it's going to be 12/5. So let's write those values down, and then I'm going to erase this work so we can actually answer the question that we were asked to answer. All right, so let's find all right. Hopefully my eraser will be faster. Okay, eraser, let's go. Let's go ahead and find the sine of S plus t. Sine of S plus t. Well, the formula is the sine of S, which is 3/5, times the cosine of t, which is -5/13, plus the cosine of S, which is 4/5, times the sine of t, which is -12/13. So when I multiply that out, I could reduce this first, but then the second one I noticed doesn't reduce in the same way, so I'm not going to reduce so that I have a common denominator after I multiply. So I get a -15/65 plus a -48/65, and that comes out to a -63/65. Okay, so now let's go ahead and find the tangent of S plus t. And that's going to be the tangent of S, which is 3/4, plus the tangent of t, which is 12/5, over 1 minus the tangent of S times the tangent of t. Well, let's go ahead and add these fractions. I know that this is going to be 15 plus 48 is 63/20. And this is going to be 1 minus 36/20. So when I do my subtraction, I get 63/20 over -16/20. And when I eliminate the 20s so that I don't have a complex fraction, I get -63/16. All right, the only thing left to do is to find out what quadrant S plus t is. Well, if the sine of S plus t is negative, and the tangent of s plus t is negative, where is sine and tangent both negative? Well, sine is negative in Q3 and Q4. Tangent is negative in Q2 and Q4. So the only one that's in common is Q4. So S plus T is in Q4. All right, we probably have time for one more example here. So this time we're going to find the cosine of S. The same thing, the sine of S plus T, tangent of S plus T. So we need the sine of S. We need the cosine of S. We need the sine of T, the cosine of T, and then we need the tangent of S and the tangent of T. So let's get started on finding those. So we currently have, let's see, -1/5 for the cosine of S. The sine of T is 3/5. And both of our angles are in Q2. So let's use our Pythagorean identity to find the other two values. The sine squared of S plus cosine squared S. Cosine is -1/5 equals 1. So when we square that, we get 1/25 equals 1. And then we get sine squared S equals 24/25. So when we take that square root, okay, so what perfect square goes into 24? Well, it's going to be 4 times 6 and then over 25. So when we take that square root, this is a Q2 angle. Sine should be positive, okay, positive in Q2. So I'm going to get 2 square root of 6 over 5. When I find the cosine of t, I'm going to do the same thing. I'm going to say sine of t squared plus cosine squared t equals 1. So I get 9/25 plus cosine squared t equals 1. So cosine squared t is going to be 16/25. When I take the square root, cosine should be negative because it is a Q2 angle. So I'm going to get 4/5. So now when I find the tangent of S, it's the ratio of the sine over the cosine of S. So I'm going to get -2/6 for the tangent of S. And then for the tangent of t, I'm going to get 3/5 over -4/5. So I'm going to get -3/4. All right, so now we're just left with finding the values that they wanted us to find for the problem. All right, so let's start with sine of S plus t. I know that's going to be the sine of S, which is 2/6 over 5, times the cosine of t, -4/5, plus the cosine of S, which is -1/5, times the sine of t, 3/5. So I'm going to get a -8/6 over 25 plus a -3/25. And I can join that into one fraction. Let's see. Minus 8/6 over 25. Okay, I'm going to stop there and I'm going to start the next video, which will continue on with this problem.